All right, so before in 12b we learned the chain rule, and that was how do you find derivatives of composite functions. And today we're going to learn about the product and quotient rules. So how do you find derivatives of products and quotients? So two functions multiplied together or two functions divided. So here's our product rule. You can see we have two functions, f and g, and it's going to be function f times the derivative of function g plus g times the derivative of function f. And it doesn't matter what order you add these in. So if we call this function f, then we have f of x equals 3x minus 2x squared. And we have g of x is going to equal, 5 plus 4x. And we're going to find the derivative of each of these functions separately. And this is going to be 3 minus 4x. And the derivative of g of x is equal to 4. And then you're going to multiply f times the derivative of g of x. So that's going to be 4 times 3x minus 2x squared. And you're going to multiply g of x times the derivative of f of x. So plus 5 plus 4x times 3 minus 4x. And we could simplify this. And if we combine like terms, I think I'm doing this right. I hope I don't make a mistake. We get this. All right, so we try this one and then check your work with mine. So I'm going to take the first function and multiply it by the derivative of the second function. Plus the second function times the derivative of the first function. How'd you do? Did you get it right? You got it down? We're going to make it a little bit harder. I'm not going to simplify this, but I think it's okay to leave it like this. All right, how about this one? This one's a little bit trickier. So we have our first function, it's the square root of x, and our second function is 3x plus 2 squared. We need to find the derivative of both of these functions separately. Pause the video now and see if you can do that. Don't forget the chain rule. The derivative of the square root of x, did you remember to write that as x to the power of 1/2? And if it's x to the power of 1/2, then our derivative would be 1 over 2 square root x. How'd you do? Did you get that one right? Because you multiply by 1/2, you subtract 1. 1/2 minus 1 is negative 1/2. And if it's the power of negative 1/2, we bring it down to the bottom. All right, the derivative of g of x is 2. Use the power rule. Times 3x plus 2. And then don't forget to multiply by the derivative of the inside, which is 3. So if we simplify that derivative, we get 6 times 3x plus 2. And now we use our product rule. So the derivative of y is f of x, so the first function, times the derivative of the second function, plus the second function. Let's see if I can do a new color. Times the derivative of the first. I'm just going to see if we can simplify it a little bit. I'm not going to multiply and distribute by any means. Could get a common denominator here to add these two. And we would get 12x You might notice there's a common factor here of 3x plus 2. So maybe take out that factor. You're left with 12x plus a 3x plus 2. And then from here you can simplify, combine like terms. 3x plus 2 times 15x plus 2 over 2 square root x. And that is our derivative. We know it's simplified because it can't be factored anymore in the numerator. Nothing can be combined. And we've added our fractions. They have a common denominator. So we are done. Try this one on your own. And then check your work with mine. First, I'm going to divide it up into the two separate functions. I'm going to take the derivative of both functions separately. And of course, we have the chain rule here, so the derivative of the inside is 2x minus 3. All right, so first times the derivative of the second. Actually, I'm just going to write this as 5x cubed. Plus the second function times the derivative of the first. And I'm just going to leave it like that. You could take out a common factor here, but I don't think that it would simplify really to anything better. Because I'm definitely not going to expand this binomial to the fourth power. So we'll call it good. All right, you can start your homework for the product rule.